Alright students, so we're going to be looking at limits and specifically solving limits with graphs and tables. So what's a limit? Well, let's do a little bit of recollection here. So let's say you got a function and it's coming along here. We'll call that function f of x. Oh, it has a hole right there. Okay, that's interesting. And we've got some values on the x-axis, 5, 10, 15, 20. Got some values on the y-axis, 1, 2, 3, 4. Have a very clear dot right there. I mean, there's lots of dots, but whatever. So we could say that f of 10 is equal to 4, and f of 20 equals does not exist because there's nothing there. It's supposed to kind of line up with the 2, but there's a hole there. Sorry, no value there. But what if I kind of wanted to know what the y value was of f of x? What those y values were approaching. Like, what are we getting closer to here? What values? What are they approaching? What are they getting closer to as the x gets closer to 20? So as the x get closer here, see, we're getting, what are we approaching? What y values are we approaching there from the left or from the right? All right. Well, in math, we have a special notation. We call that the limit of f of x as x approaches 20. We actually have a technical name for that. And we can look at this in two ways. We can look at it from the left and from the right. If we look at it from the right, we kind of think of that as from the positive direction, so to speak. If we look at it from the left, it's the negative, even though in this case it would still be positive values, but positive is on the right hand side, negative is on the left. So here is our official notation. Lim, and I'm going to do a little cursive L there so it doesn't look like a 1 or anything. So, but we'll pronounce it the limit. The limit of fx as x approaches 20 from the right. And I say from the right because there's a little plus sign right there. Equals, okay, as we go here from the right and we come down here from the right. Oh, looks like it's approaching that 2 value. So I'll put equals 2. And we could say the limit of fx as x approaches 20 from the left, that's a little minus sign in that superscript notation. Look up here, and also equals 2. Okay. So we'll change color here. So since the limit from the left and from the right are both approaching the same number, and so we could say that they're equal, we can say that the limit of f of x as x approaches 20 equals 2. So this is what's called the two-sided limit, when you actually don't have any value, a plus or a minus in that superscript notation or location there. So there you go. So just to write it down in words, what I've been saying out loud, we would say the limit of f of x as x approaches 20 is 2. Hooray! All right, so let's go ahead and get a new page here. So here's some things that we definitely need to make sure we're super clear on. Okay, f of 20 does not exist. The function value is completely empty at 20. There's nothing there. There's a hole. However, the limit of f of x as x approaches 20 equals 2. These two things are different. F of 20 means what point is there on the graph? And the answer here is there isn't a point. This one says, what are we getting closer to? All right, so make sure you have a clear distinction in your mind that there's a difference between the function value and the limit of the function as x approaches a certain value from the left or from the right or from both sides. Okay, so now we're clear on that distinction. So we're going to look at some special cases here. So for instance, sometimes the function jumps at a point, but to make it clear, the limit is what the function is approaching. Okay, so just kind of reiterating that last point. and the limit is always asking, you know, what are those y values? So here's a regular straight linear function, h of x, except for whatever reason at 3 there's a hole in it, and it jumps up, and this is supposed to be at 200, but apparently I can't line things up on the screen here. So anyway, so h of 3, the actual function value is, okay, no, that's how I'll link it to, 200. However, the limit of h of x as x approaches 3, look at it from the left, look at it from the right, is, oh, there's the wait for it, 100. Once again, these two things are different, h of 3 and the limit of h of x as x approaches 3. Okay? It may be that sometimes in some functions, in some situations, those things happen to be the same. You know, the values on the right hand side are the same, but that's just sort of coincidence. But is that what we're asking here, h of 3 versus the limit of h of x as x approaches 3 are different things. All right, I think you get that idea. I don't need to share that anymore. So, what are some other special situations we can have? If the one-sided limits on each side are not equal, then the two-sided limit, wait for it, does not exist. If the limit from the left does not equal the limit from the right, then we would say the two-sided limit doesn't exist. Here's a crazy piecewise function. So there's f of x. It's linear over here, it's linear over here. There's a hole right there. There's a filled-in circle right there. The limit of f of x as x approaches 3 from the left is up here, 5. The limit of f of x as x approaches 3 from the right, so let's go marching on one by one along the line here, is 1. Okay, because it's kind of supposed to be lined up like that. So what's the limit of f of x as x approaches 3? Like, you know, straight up, you know, no plus or minus. And the answer is does not exist, because from the left it's approaching 5, from the right it's approaching 1. Doesn't exist. Now, just for your information, f of 3 is right there, 1. That's where the function value is. All right. Let's look at some specific problems that you might face in your homework. So this is the function f is graphed below. Find the following limits. If the limit doesn't exist, right? Does not exist. All right, then we will. This says the limit of f of x as x approaches -2 from the left. So notice minus there from the left. So here's -2, approaching it from the left. Oh, looks like we're approaching +2 on. And remember, the limit's always asking about what's the y value. What's the y value of the function there? Here we're asking the same thing about -2, but from the right, and we go. Oh, that's 0. So since those two things are not the same, the two-sided limit right here does not exist. Now, I think I just want to highlight here. Hey, look at this guy. All right, let's just do a little bit of a separate problem there. Okay, here we go. We'll look at this one. So this is h of x. The limit of h of x as x approaches 3 from the right is 2. The limit of h of x as x approaches, 3 from the left, 4, and so then it doesn't exist. Great. Another one exactly like the previous one. So let's find a part here. So what about the limit of h of x as x approaches -1 from the left is -2. The limit of h of x as x approaches -1 from the right is also -2. The limit of h of x as x approaches -1, sorry, is -2. Hey, that's great. Everything's approaching that hole right there. Now it never actually hits there because the function evaluated at -1 is whatever, 4. So I think I made a note of that. Even though h of -1 is equal to 4. Yeah, okay, we get it. They're different things. Okay, well, sometimes you're going to have limit problems where they don't give you a graph. They will give you a table, and they want you to basically do that same kind of thing with a table, sort of see what happens as you get closer and closer. Now, if you wanted to, I guess you could graph it and then try to eyeball it here. But if you look here, we have they want us to fill in the missing numbers of the table and then use the table to find the apparent value in the following limit. So limit of square root of 9x minus 9 over x minus 9 as x approaches 9. And you're like, okay, round your answers 4 decimal points. So here they have x values, x of 8, and they plug it into the function here. They've got a horizontal function table, but that's okay. You plug in 8 into x up here, and you get 0.5147. You plug in 8.5, you get 0.5071. You plug in 8.95, you get 0.5007. Okay, that's kind of cool. But what do you get when you plug in 8.99? And we can maybe see some sort of trend. And then what do you think it will be for 9? Obviously, we can't just plug in 9 here, because if you would have square root of 9 times 9, that's just going to be square root of 81. So that'd be 9 minus 9 is a 0 in the numerator. Who really cares about that? But what we do care is that there would be a 0 in the denominator here. And you can see here they have down on the right hand side they have 10, then 9.5, then 9.05, then 9.01, and so we're obviously zeroing in on or closing in on 9 from the right here. Okay, how can we do all this stuff? Well, you can plug it all into a calculator, or we can go over to our friend Desmos and type in the function rule. Here you go. So I'll do square root 9x minus 9. Check the formula. All over x minus 9. There it is. Great. So remember, you have to hit that gear thing there and then choose table, which I did so fast you probably didn't even see it. And then over here on the left hand side we can plug in those values. I'm going to plug in 8, then 8.5, then 8.95, just to verify that the formula that I typed in is a match for this formula right here, and it is. So I'll plug in 8.99. I can zoom in a little bit here. There's 8.99. Looks like 0.5001. I can plug in 9. There we go. Yep, it's undefined. They're not going to have an open circle here on Desmos because they don't have it programmed to do open circles for undefined. Plus, I get to continue to zoom in almost forever, or at least until the program reaches its maximum resolution possible. So I'll put 9.01, 9.05 just for fun, 9.5 and 10. It's kind of neat to see those dots there, kind of see how we're definitely getting closer and closer, closer and closer. So there we go. I'll grab those values, 0.5001 and 0.4999, whatever. Put those values in there and then see that it approach 9. So anyway, so what we've looked at here is what actually a limit is. And then evaluate limits by looking at graphs, evaluate limits by looking at tables, and we've looked at it from the left, from the right, looked at the two-side limits. We've evaluated and seen how limits are different from the function value. Just had to throw that in there one time. And I wish you luck in all your limit endeavors.